Ensure you install the NHANES package. We are going to be making use of the data sets there. So you can even check more about it if you want to find out about. So if you want to get help about a package, we are going to be using the double question mark, unlike the single question mark that is being used for a function. So can you see it? This is it. This is the data set that is part of the NHANES package. This is it. So it's a survey data collected by the US National Center for Health Statistics, conducted a series of health and nutrition surveys since the early 1960s. So these are the details, and you can see more about it and also the various variables. So I'm going to be making use of the BMI column in this particular data set now. You could explore it more. So now let me just run this particular place, BMI data. And when I run BMI now, I'm going to say, just to look at the vector that we have. So this is the vector. You can see we have missing values. So this is the data with missing values. So I'm just going to omit or remove the missing values by using the na.omit function. Then I'm just going to run that, and I'm going to call the BMI data again, and you can see the missing values has already gone. So you can actually take the length to see 9,634. So let me run this to just see how many missing values we have. So you can see initial was 10,000. The now without the missing value, we have 9,634. So this is how we are going to. I'm just going to make sure we omit those missing values. Okay, so first now we are trying to calculate the quartile. So if you want to calculate the quartile, use the quantile function. So the quantile function now, if you check it, belongs to base R. So it's actually in base R from the start package. This is just part of base R. Now we are going to be using the quantile function. So what the quantile function, first of all, you have to give your vector, which is the BMI data that we see we give, and you give this other argument, which is called the props. So if you check this particular quantile function, and the props, the numeric vectors of probabilities with values 0 to 1. So these are your values now, where 0.25 means the 25th quartile. 0.5 means the 50th. So now this particular props argument takes probability values, as you can see, numeric vector probabilities with values. Now, if you look at it here, you can see that I told you earlier on that the 25th percentile is the first quartile. The 50th percentile is the second quartile point, while the 75th percentile is the third quartile point. So that is why, because this takes a value of 0 to 1. And 0 to 1 can be represented in percentage. So 0.25 is like 25%, 0.5 is 5%, 0.75 is up to 1. So we know that 0 to 100 can be represented as 0 to 1 in terms of probability. So that is why you have to make sure you know your percentile equivalent, because that's the value you are going to be given inside this particular place. So 0.25 is your first quartile point, 0.5 is your second quartile point, 0.75 is your third quartile point. So when you run this now, I run this particular value. Okay, I need to remove my missing values. I now run this. You can see I now print the quartiles. So you can now see my first quartile point is 21.58. Second quartile point is 25.98, and third quartile point is 30.89. So those with BMI 30.89, them is they are in the 75th percentile, which is the third quartile. They form around that. So anybody with value above this, anybody that has a BMI above this falls in the fourth quartile group. Anybody with value above this but below this falls in the third quartile group. That is BMI. Anybody with a value below this but the value is above this falls in the second quartile group. But anybody with a BMI value below this falls in the first quartile group. So you can know which you can. This why this is very important is that you use this in categorizing. You can use this to categorize it into 4 BMI groups. You say, okay, these are those with low. You can now say middle, or you can combine the second and third quartile group into one and say these are those with average, and those above this particular value, you say these are those with high BMI. That is one of the importance of quartiles in statistics. It's usually used when you are trying to categorize a numerical value. It's usually used. I know that I used this when I was doing my master's project to classify my dependence variable, which actually comes in the form of a numerical or continuous value. I actually have to categorize it to create more meaning, because when you categorize a variable, you create more meaning when you are trying to interpret it. So categorization is very important. So this is one of the uses where quartile comes into our place. So we also have what we call deciles. The deciles that we are seeing, we also follow the same approach, but this time around we have to look for the percentile equivalent. So the percentile equivalent of the 10th decile is 0.1, and for the 90th, 9th decile is 0.9, and by 0.1. So what we did here now, here we just gave a vector because we are calculating quartile. But you know, for a decile, we are dividing it into 10 equal parts. So if I should carry this code now, this sequence function creates a vector sequence with a step of 0.1 from 0.1 to 0.9. So this is what we are having now. So instead of just writing this, I'm just using the sequence function to just make it easy for me. So this is what I'm going to be applying to this quantile function. And when I run it now, I get my deciles, as you can see. Anybody BMI below this falls into the first decile group. Then the same thing also for this time around for the percentiles now, I'm going to be starting from 0.01, which is 1%, to 0.99, which is 99%, giving a step of 0.01. So when I take this, I show you the sequence. So you can see instead of repeating all this with hand, that's why I'm using the sequence function. So each of these is the first, second, third, up to the 99th percentile. So this is what I'm trying to get. So we know that any value below this falls into the bottom first percentile. Anyone with value above the falls above the 99th percentile. So when I run this also, I get this and this. But most of the times in practice, this quartiles is usually used a lot because you cannot categorize data into 100 parts or categorize data into percentiles. Sometimes when you categorize your data into percentiles, like I told you about my master's dissertation, what I did was that, okay, I picked some values below 40 percentile, which is this, because I just picked value below this. I can categorize them as low in my dependent variable. I now picked value above 0.4, which is the 14th percentile, and those below 0.60, which is 60th percentile. I categorize them as average. I now picked values above 0.60, and I now pick values above 0.0 as high. So this is what I did. So sometimes you might need to categorize using a percentile. You can need to divide your data into a using percentile and categorize. And sometimes you can make use of decile. Most of the times in practice, quartiles is used a lot, and at times percentiles also, which you can use to. These are the various measurements of partition which you can use to partition your data sets.